All right, let's jump right into this explainer and explore the fascinating industrial process that, quite literally, holds our modern world together. We're talking about gas metal arc welding, or GMAW. I am absolutely thrilled to walk you through this today, mostly because welding is one of those invisible forces we rely on every single day without even realizing it.
Think about the towering buildings you work in, the steel bridges you drive across, or even just the car sitting in your driveway right now. How do all those massive, totally distinct pieces of metal become one solid, unyielding structure? Well, today we are going to demystify the exact process that makes their construction possible. We are literally looking at the seams of our modern infrastructure.
So, here's our roadmap for today. We'll start with the evolution of GMAW, then move on to building the modern world, weighing the pros and cons, and finally, mastering the weld. Let's kick things off with Section 1, the evolution of GMAW. When you look back at early industrial applications, especially things like shipbuilding and aircraft manufacturing, early gas metal arc welding was just incredibly expensive. And you might be wondering why. Well, because it relied almost entirely on really pricey inert gases like argon and helium just to protect the molten weld pool from the surrounding atmosphere. So yeah, it was highly effective for non-ferrous metals like aluminum, but that high cost severely limited how widely it could actually be used across other industries. Here is how the timeline played out. In 1948, the Battelle Memorial Institute officially develops and patents GMAW. But the real evolutionary leap? That happened a few years later in 1953. The breakthrough of using cheap active carbon dioxide suddenly solved that massive cost problem overnight. This single innovation made economical, mass steel welding totally viable. It transformed GMAW from a niche aerospace and shipbuilding tool into a booming, absolute industry standard.
So a crucial point of terminology to understand here is the difference between MIG and MAG, because you've definitely heard these terms thrown around. MIG stands for metal inert gas, which refers to the original use of those expensive, non-reactive gases like argon or helium we just talked about. MAG, on the flip side, stands for metal active gas, representing that revolutionary shift to using the active, highly cost-effective carbon dioxide. Now, the mechanics of the wire and the arc, those are exactly the same, but the gas fundamentally changes the economics of the whole shebang.
Moving right along to Section 2, building the modern world. In the automotive industry, GMAW is absolutely foundational. I mean, it's heavily used to manufacture and assemble the very frame of your car. But it's not just humans holding the torches anymore, right? The industry integrates these insane robotic welding systems. These massive, automated arms use the GMAW process to deliver unmatched precision and blistering speed, which is exactly what you need to keep up with the wild demands of global auto manufacturing.
But it's not just moving vehicles. When it comes to the towering structural steel of commercial buildings, massive suspension bridges, and high-stakes pressure vessels, this process is essential. Out there on a job site, GMAW produces the incredibly strong, highly durable weld joints required to handle massive weight loads. And ultimately, that's what keeps the public safe.
And let's bring it back down to a smaller scale for a second. It is also the absolute go-to method in general maintenance workshops and local auto body repair shops. Mechanics and techs just love this process. Why? Because of its overall ease of use compared to other welding types, and its ability to consistently produce incredibly clean, precise welds when they're fixing up collision damage. Which brings us to Section 3, weighing pros and cons.
Welders are constantly facing a dilemma. It's a classic trade-off. On one hand, you have incredible advantages. It's easier to learn, totally slag-free, delivers high productivity, and gives you deep penetration. But you have to balance all of that against strict environmental sensitivities, access limitations, fusion risks, and higher equipment costs. Let's actually break these down a bit more.
On the plus side, it requires way less skill to pick up compared to older or alternative manual processes like TIG or stick welding. Plus, the high deposition rate comes from a continuous wire feed, meaning drastically reduced downtime. The faster you weld, the less heat concentration you have, which leads to lower heat distortion of the metal. And honestly, perhaps the best part for the operator, since it uses a shielding gas instead of a flex coating, there is absolutely no messy slag to chip away. We are talking zero cleanup afterward.
However, the welder's ultimate nemesis outdoors is an invisible enemy: wind. Because this entire process relies on a delicate little cloud of gas to protect the molten metal from the oxygen in the air,
A simple, unexpected gust of wind can literally blow away the shielding gas. If that happens, the atmosphere contaminates the weld pool, creates immediate structural defects, and completely ruins the weld. Additionally, the gear itself creates some limitations. Unlike simpler grab-and-go methods, GMAW requires heavy gas cylinders, specialized wire feeders, and delicate regulators. This inherently means a significantly higher initial equipment cost, and it makes the whole setup far less portable.
Building on that, because the torch has to feed a continuous wire and channel gas at the exact same time, it is pretty bulky. That makes it super difficult and sometimes flat out impossible to use in really tight, confined spaces. Furthermore, it is definitely not foolproof. If the operator dials in the incorrect machine settings, say matching the wrong voltage or wire speed to the metal thickness, there is a severe risk of incomplete fusion in the joint. That creates a weak bond that could easily fail under pressure, and nobody wants that.
Finally, let's look at Section 4, Mastering the Weld.
So the main takeaway from this explainer is that GMAW is undeniably one of the most versatile and highly productive processes we have available today. But success isn't just pointing a gun and pulling a trigger. True mastery requires a delicate, highly informed balance. A welder has to successfully match the precise correct filler wire and the specific type of shielding gas directly to the exact chemical composition of the base metal. When all those factors are perfectly mastered, it enables welders to produce the strong, efficient, and exceptionally high-quality welds that our modern infrastructure literally demands.
I'll leave you with this thought. The next time you cross a towering steel bridge, or even just hop into your car to run an errand, I want you to really look around. Just wonder about all the hidden, perfectly mastered seams holding your world together right in that moment. Every single one of them has a story of extreme heat, precise chemistry, and decades of industrial evolution. Thanks so much for joining me for this explainer, and hey, keep looking closely at the constructed world around you.